So yesterday we developed something called the law of sines, which sounds strange. But thankfully we had, avocados and sleepy pandas to help us. I need to rediscover. Here it is. Okay. Good Lord. The things I do to myself. So we're going to finish this out in a second, but just to remind everybody, kind of like where we got to, we developed, I'm not going to redo it. We developed this law. This is true for which triangles? And to be really honest, Layla, any triangle, even if it is right. Let me see if I can. Here. I want you guys to see this. So if I have the right triangle, and let's say this is 3, 4, 5, yes? And let's say this is obviously C. Let's say this is B, and let's say this is A. You guys with me? So this says like the sine of C over C is equal to the sine of A over A. Are you guys, is that cool? So if you weren't here yesterday, fundamentally, and this is kind of cool, if you watch the video, you can see how this shakes out. There's no reason to expect this to be true, but we proved this is true yesterday. And I want to take a second, I always forget to do this. I want to show that this boils down to what we know already. If it is a right triangle, I'm feeding it. Do y'all agree with me that C is 90 and side C is 5? Is that cool? A, I don't know, but side A is 3. Is that cool? What is the sine of 90 degrees?
1.
Yes. How do I solve this for sine A? How do I solve it for sine A? What do I want to get rid of? I want sine A by itself. So when I get rid of, what do I get rid of so that sine is by itself? The 3. I want to kill the 3. How do I kill the 3? Multiply both sides by 3. So sine A is 3/5. We got this result from this. Yes? What is sine A? Just look at the triangle. What's sine A? What's sine in general? Which side over which side? Sine likes y, so don't overthink this. This is just one of the first problems we did. I gave you all the sides. What's sine A? And since it's a right triangle, I could just see it, but this will still work. Look, that's what it told us. It will still work. So this isn't new. We are catching up with what's true. If C is 90, this is 1. And then it kind of boils down to all the stuff we memorized for right triangles. This is the larger idea that C equals 90 is one small example of. But when C is 90, we got all the shortcuts we can do. If C is not 90, if there's no 90-degree angle, then I've got to use the full-blown law of sines. Yeah.
On the equation.
Yes.
Can you put like any sine under it? Like can you put sine of 90 over 5?
Why did I do that though? I did that for a very specific reason. 90 can only go with 5 because angle C is 90 and side C is 5. I could not put sine of 90 over 4. That wouldn't make any sense. What does this law say? The sine of an angle over its side. The side across from it. Yes? So when I draw a general triangle nowadays, not necessarily right 90, if this is C, this is angle C. If this is side B, this is angle B. If this is side A, this is angle A. Just to make it easy to illustrate, right? We could have chosen any damn thing we wanted to, but this makes sense to me. Capital A angle has stick A in its mouth, and so forth. Okay. So they have to be an angle in the sine over the side that goes with that angle, the side across from it, yes. Otherwise, it would go to shit. It wouldn't work. Yeah. Okay. So if you were here yesterday, you saw all this. I don't want to finish that triangle out. If you were here yesterday, can you remind me what situation we have to be careful about?
Having two opposite triangles.
Yeah, when might that happen?
When the angle that you're solving for can subtract and it's going to be less than 180. Or angle sine sine.
Yeah, angle sine sine. So if I give you an angle, and then the side next to it, and then the side next to that. Yes? So if I do that, maybe it makes a triangle, maybe it doesn't, maybe it makes two, because maybe this can swing over here. Now listen, if you weren't here yesterday, you desperately want to watch that video. I'm not going to redo all of this, I'm very sorry. You guys with me? But here's the thing. We should expect that any process where I take inverse sine can lead to weirdness. Does anyone remember inverse sine? What are the outputs possible? In order to have inverse sine exist, we had to chop a bunch of shit off. So because of that choice we made, what's the outputs for inverse sine?
Pi to
Negative pi over 2 to pi over 2.
yeah.
Could a triangle have an angle bigger than pi over 2? Of course it can. A triangle, not a right triangle. A triangle. I could have a triangle that has an angle almost 180 degrees. It would just be, and then it would be this little sliver of a thing. You guys with it?
Yeah.
So totally I can have an angle. So any process in the middle of which I take an inverse sine, and it's an answer, and the answer could be more than 90 degrees, I should expect weirdness, because inverse sine cannot give me more than 90 degrees. But physically, if you were here, I showed you an example, and it literally is, if that's side B, there's a triangle, but I could swing this over, and I can make a whole other triangle. There's two possible triangles. Or there's only one, or there's none. If side B was too short, I guess I am going to sort it, do it all over again. Why not, Jeff? If side B is too short, and I need this angle to be this big, can I ever make a triangle out of this? That's how long B is. And here's the angle, so this is where the side has to be. Could I ever make a triangle out of this? No, I could swing this back and forth all day. It's never going to reach this. It can never make a closed triangle. Do you guys see that? That is the geometrical interpretation of the mathematical problem with inverse sine. Okay, that's really cool. This is kind of like baby steps into you guys realizing some problems are easier to understand if I change the form I'm looking at it. Not just mathematical, let me see geometrically, does it make more sense? To me, this is really physical. Geometrically, this makes sense. If that last piece is not big enough, I ain't gonna reach that side, I can't make a triangle. If it is big enough, maybe I make two triangles. Or maybe it's exactly the right size and I only get one triangle. There you go. Okay. So we're in the middle of a problem where we set up the law signs. We got the angle. Come back. Go away. Go back. Thank you. Okay. We got the angle. We called it C1 because we had to check. Now, can somebody remind me who was here yesterday? When we got this angle, how do I check to see if another triangle exists? Where the hell did we get this from? Yeah, so maybe it's good for everybody. So if I have this situation here where this could swing and make another possibility, I'll get one possible angle here, and then I get the other possible angle is 180 minus that one. So if one triangle has this angle in it, if there is a second triangle, it would have to have 180 minus this in it. So if I got 20 here, this would be 160. If I got 10 here, this would be 170. Now, how do I know this is good? How do I know this means there's a second triangle? What was the angle that we knew in the triangle from the beginning? What did we know from the beginning? 31 degrees is already in there. So if this is in there, is there room for a third angle then between the two of them? Yeah, because that doesn't add to more than 180. So that leaves room for a third. So if this would have been, you could do it, Jeff. That would have been 160. Would there be a second triangle? Because 160 plus 31 is already bigger than 180. I can't make a triangle when I can't even have the last angle exist. Maybe you guys are with me. This is trippy, but you can see the idea behind the steps we do. The picture shows me why I do the picture that I don't know what I've done with now. Why I do 180 minus. That shows me why I do 180 minus. And then physically, if that wanted to be an angle in here, could it be in here? If that was 160? No. It's 124? Yeah, it could totally be an angle in there. Okay. I don't know if everybody's caught up with me now. We'll find out. So that's one triangle. We finished this last time. Now what's hilarious to me is if you're organized, this work is almost too easy to believe. Everything we did here is exactly what we do over there. I just used that number instead of this number. So where did we get this from?
Depending on what C is, it could.
Yeah, we know A is 31. So in this case, 31 plus 55, take away from 180, that's how much was left for the third angle, yes? Now, 31 plus 124, how do I figure out what's left over for the last angle? I really want everybody with me. If I shove that guy here, and by the way, here's the, do y'all agree with me that's less than 90 based on how I drew the picture? Okay, that goes with this, yes? If I swing it in, so it's the same length. See, that's the same length. Now look at this angle. That's bigger than 90, right? That's this. Less than 90. Swinging over, bigger than 90. Do you guys see that? Okay. I can't tell. Sometimes I wonder if people are just going like this just to make me happy to keep going. Just keep going, Jeff. Dear God. Okay. So 124, 31, 124, 31, what's left over for this dude? When I add these together, I get 155.507. So if I do 180 minus that, I see what the last angle is. That would be 24.493. Is anyone doing that for me? 24, right? 0.493. Go, Jeff! It's my one job is to do the math. Okay. And okay, what were we doing here? At this point, we knew everything except side B. So this was the work to get side B. Now here's what's funny, and I hate that I had to do this across 2 days, but that's the ratio we could make from the beginning. We knew 31, we knew 10. So I always come back to that ratio because that's the one I know is right. And then the other ratio I can make now, I want to figure out side B, yes? I don't know what side B is. And to do that, I just put sine of angle B up here. So it's all the same work because I have all the same shit to find. I have all the same stuff to find. I'm just doing it based on a different original angle here, yes? So now I can solve this for B. Multiply that up. Multiply that up. What are you trying to be? There. Divide this down. And that should be like, yeah, like, what do you get? 8.05? Okay, and why does that make sense? I know there's a lot going on. In this triangle, the smallest angle is B, yes? So the smallest side should be B. And sure enough, if you look at all the sides, that is true. You can always do that in a given right triangle. The largest mouth should be crossing the largest side, smallest from the smallest side, so forth. Okay. So law sines has got a lot going for it. It's relatively easy to remember, which is good, because you have to. You have to remember that shit, yes.
The way I made it like more like organized was at the end I put a table that had angles on the sides. So kind of like just right next to each other.
Oh, sure, yeah. So you can organize your answers, sure, yeah.
I can put triangle 1 and like a T sign.
Yeah, so you got B2,
And that
B2,
helps you, like,
B2,
make it
C2, yeah.
A lot more cleaner. After.
Yeah, totally, yeah. And it's really good for the person grading your shit. Make sure that they can find your answers.
Yeah.
So I have one angle, two sides I know, so that means I have to find two angles and one side to finish the problem.
Yeah.
Two angles, one side. Yes? Okay, maybe. So here, let's do this. Let me make up a problem. That's always exciting. Before we learn the other law, I am the lawgiver. Let's try to solve this triangle. Bum, 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 bum. Okay, let's see if I made one that works. This should be exciting. It's very possible this will have no answers, which is a good example to look at anyway. Now, it's not a bad idea. It's not entirely necessary, but it's just good to do. So, like, 71 degrees is a little less than 90, so there's C. C is 13 and B is 9, so it doesn't really matter truly, so I'm just going to do this. So this will be, let's say that this is B, so this is 9, and let's say this is 13, so this is A, and this is little a. Okay. So you do the best you can. So at least I got 71 degrees, making sense. The side for 13 should be 1, who cares? Doesn't have to be perfect. Why do I know law signs is going to work here? What is it about this problem that tells me law signs will at least be the right way to go? I can make a complete ratio. So if I have an angle and its associated side, that's what's required for law signs to work. And algebraically, why does that make sense? I can't solve an equation that has too many unknowns. So if I can't make a complete ratio, I'm not going to be able to set up an equation with just one unknown. Okay. Okay. So what's the ratio that I can make? Good. So everything to do with C. And then the only other one I know anything about is B. Good. So I don't know shit about A right now, so I can't, there would be too many unknowns if I tried to solve for the A business. You guys get that? Algebraically, it makes sense. I brought calculators in case you need to borrow one, but what am I trying to solve for here? I'm trying to solve for B. I want to know what angle B is. So what's the first step to get there? Nope. Multiply by, I gotta get a 9 out the way first so I can attack the sign directly.
9 side was 71?
Yes, good. So I multiply by 9. And real quick, I have to do that because I want my inverse sign to directly attack my sign. If there's anything else there, it's in my way. But now I've got sign alone. Now if I attack both sides with inverse sign, if I take the inverse sign on both sides, it'll kill that sign. And I want to know what side, what sign. what angle B is. So if I take the inverse sine of both sides, try to plug that in your old calculator. Make sure you're in degrees, of course. Oh, that's days. Here we go. Okay. You wanted another. I might have copies. Maybe, I don't know. Oh, let me catch up here. So make sure you're in degrees. Yay! And then, let's see. I'm just gonna let the calculator worry about all this. Inverse sine of 9 times sine 71, close the parenthesis, divided by 13. I made one that works. Sorry. So I get 40, Jeff, 0.889. So that's B1. If B2 exists, what would it be?
180 minus that.
Yeah, what's 180 minus this?
139.111.
Yes. Is that a valid possibility?
Yes.
How do you check? What angle is in the triangle already? What angle's in the triangle already? If I try to shove this into it, it's already over 180. I need you to understand that when I do a problem mathematically, I can get a number answer. That doesn't mean it makes physical sense. You guys with me? Like back in algebra, you could solve an equation for how many hot dogs somebody ate. And your answer, mathematically, you get -3. What does it mean physically? Did they somehow produce 3 hot dogs? I don't know what that means. I want to stop thinking about that. Right? So the math can give you a number. The math gave us this number. Everything we did mathematically was perfectly right. It's just to go, oh, that doesn't lead to something physically existing, so I'm going to forget about that. So we finally see an example where we only have one triangle that works. Die. Okay. So only one triangle works here. I don't even need this. Go away. That's nice. Then you go, oh, thank God. So what can I immediately get now that I know this?
A.
So when I do this plus 71, and then I can subtract that from 180.
68.111.
Yes. And then what's the only other thing I don't know yet? I have all 3 angles, yes? Do I have all 3 sides? Nope. What side do I still need? Which side? A. So I can make the same ratio I made. I can always go back to that because he's always good. That's what I was given. So I know this is true. And now I can equal this to what?
Sine 68.
Good. Sine of A
Over.
over side A. Good. So if you say to yourself, oh man, I need side A, well, you're going to have to use angle A to make that show up. All right, go ahead and solve that. So again, this should be like 11 point something maybe. Let's see. Ah, 12 point. I get 12 point something.
Well,
Did you guys get something
I got
different?
13.246.
Ooh, no. Real quick. This, you never have to do what I'm about to say, but real quick. Which one is bigger between these two signs? How in the world would you know? Well, because when does sign get bigger? When the angle gets you closer to the y-axis. Which one of these angles is closer to the y-axis?
71.
Yes, so the bottom should be
Yeah,
bigger.
got it.
So this number is less than 1, you should get a number less than 13.
The sign.
Do you have to know anything I just said? No. You don't have to know anything I just said, but you can see how we know enough to realize what I just said. And that's kind of a way to make sure the answer I'm getting is right. You should get, what now?
12.758.
Good. 12.758 cows? Meters. I love it. Every now and again I want to do metrics, so those of you who are here from other countries, you can finally see a unit that makes sense. Instead of the king of England's foot size. Alright. So let law of sines. The one thing that sucks about law of sines is it could lead to a situation with no answers, one answer, or two answers. Okay. And when you have to check it is when you have angle side side. We did an example like this one. This one did not have two answers. It had one answer. Why? This one we didn't have to check because I have angle side, not angle side, right? So we had all three angles. There's no other angle it could be because if I have two, that means I have three. Okay. So what we're going to do now is going to be very exciting, and you guys see what's up on the board. So I'm gonna let's see. How do I want to do this? All right. Sure. We're going to develop, you already know we're going to develop the law of cosines. And I'm going to get your help doing it. I don't think it's really an issue to have you show up on the camera, so. But I could turn it away if you want to come up and do something and not be on the video. I don't mind. So. What I need help with, I'm going to do one little thing. What kind of sucks about the triangle I've drawn here?
It's not a right triangle.
Yes, not only is it not a right triangle, is it easy to find a right triangle in it? No, but I'm going to do something different from what we did yesterday. If I drop a line straight down, didn't I make a right triangle now?
Yeah.
And did I make two right triangles? There is a small one and there is a big one.
Yeah.
Okay. You guys see what I'm saying? Okay. This derivation is a little worse than the derivation for sines, but you can still handle some of this. I just created something that isn't really there, yes?
Yeah.
But you can still talk about how far this is and how far this is. So, let me ask you a really silly question. Does anyone know how long this whole thing is?
8 plus whatever.
Oh, okay, let's do the other way. Somebody tell me how long this whole thing is. And a great answer is, I don't know, but in algebra, when we don't know something, what do we call it? Cool. So I'm going to call this whole thing x. Which means this is how much? If this is 7 and this is 3, what's this? Yeah, it'll be x minus a. That's like what I call a cookie cutter problem. You chop part off and the leftover is what was there minus what you chopped off. Is everybody with me? Okay. This side I'm just going to call y, because I'm a creative guy. Okay. So ready with you. What is, does anyone see relationship with angle C
It's the same in both triangles.
using sine? It's not the same in both triangles, right? You gotta be careful. One triangle is this one.
Oh, you're right.
And that one, we only know the right angle. Yes?
Yeah.
I'm not gonna make you come up here, I just decided, because it's a little weird. What is sine? No, don't use that one. What is sine C? Don't overthink. Go back to basics. What is sine C?
C over A. No, C over
No, come on, careful.
You
The basic ratios for trig. What kind of triangle must they come from?
Why?
Right triangle. So I cannot do anything
Yeah.
from this unless it's in the whole right triangle. You with me?
Y over.
So what right triangle is C in? The big one.
over X.
Yes, so it's y over x. So what's y?
Sine X.
Do it again.
Sine X.
No, come on. How do I solve for y? How do I solve for y? Multiply by x, yes.
But
Is everybody with me?
would be
Go ahead.
I think the X has to be the B.
Yeah.
Like
Yeah.
the lowercase b.
Oh, why do you say y over x? Alright, thank you. So it's y over b, yes, thank you. So then y is equal to b sine c. Okay, good. What is, what's the other one I want? Let's see. Since I'm not going to make you guys come up here, I'm going to transition over here, just because it'll make it easier on me. You try to redraw that. I was going to have you guys come up, but it's okay. Okay, get over there. Okay. So let me try to capture that. Come on. How'd I do it? This was, okay, this was A, right? This was C, this was B, this was X, this is X minus A, and this was Y. Okay, so we got sine C is Y over B, Y side over hypotenuse, so Y is B sine C. Fascinating. Now what is cosine of C? Now I can bring in, don't overthink it. What's cosine of C?
X over B.
It can never reference this triangle. Why not? Why can cosine C currently not reference this triangle? It's not a right triangle. So cosine of C has to be this whole thing. Cosine of C would be x over b. Is that cool? So what is x? B cosine C. Now listen, stay with me. This is, I got the, all right. Quick little drunk history of math. Back in the day, people didn't have a lot of fun to do. There wasn't as many ways to waste your time. So if they had some time, they would get some paper, a candle, and a little quill, and they would just play with math stuff, right? Not everybody. Some of the math people would, right? What are they going to do otherwise? They didn't even have an etch-a-sketch, right? We are going to go through a derivation of a law that we're going to use. You're never going to have to redo this. I still want you to follow along. I really want every step we do to make sense, because I want you to see the law came from grounded places, right? Somewhere can tell how it came about.
What is the word derivation?
Oh, when you, like Pythagoras, derived the Pythagorean theorem.
Okay.
Yeah. So the derivation is the process he went through to see that it worked.
Okay.
Yeah. And there's like 53 different ways to do Pythagorean theorem that I'm aware of. And then there's hundreds more that I never looked up.
Okay.
So let's not do those. So derivation just means like the law signs, everything we did that led to the law signs, that was me deriving the law signs.
Right.
Right? And just don't, drink and derive. Here we are. Okay. Now let's turn our attention to the dotted dude. Yes? The other right triangle. Can somebody help me do Pythagorean theorem? Somebody help me old Greek dude that dude? Don't overthink it. How do I what do we know about that right triangle? What are the sides?
Why?
Y?
Yeah,
X minus A?
X
C. Which one's the hypotenuse? You're welcome. Because I could have made these letters however I want to, but it's just, yeah. That's definitely the hypotenuse of that right triangle, yes? So what's old Greek dude say about the dotted,
X minus A.
yeah, one side squared
Plus Y.
plus the other side squared,
Equals C.
hypotenuse squared, yes? If I have a right triangle, I don't give a shit what somebody called the sides. I know that's always true. Did we figure out just a second ago what y is?
Yep.
Go team. Did we figure out just a second ago what x is?
Yep.
Now listen, again. I always get a student that seems to forget what I just said. You're never gonna have to do this yourself. So if you're like, I would have never thought to do that. Well, yeah, you don't have years and nothing but ink and paper, We got other shit to worry about. I mean, who else is going to watch those YouTube videos? So, if I plug this in, that's what y is. That's what y is. So I'm going to replace y with it because that's what he is. And what am I going to replace x with?
B cosine.
Yeah, I'm going to replace x with b cosine c because we just figured out earlier that's what the hell he is. So what I'm doing, what was the original triangle I had? What was the original triangle I had? ABC, yes? And then I added that other shit on just so I can make a right triangle for myself. So what am I doing right now? I want to end with something that only has ABC information. Because what am I trying to do right now is I'm trying to say, if I'm given a non-right triangle, what does trigonometry look like for it? Because we know what trig looks like for a right triangle. It's how we built trig. But now we're trying to extend what we're able to do. Okay. So did I just get rid of x's and y's? I will in a second. Are all my x's and y's gone?
Yeah.
Everything in here is only referring to my original triangle, yes? So now I just want to clean this up. So I kind of created the XY thing just so I can have a right triangle to talk about. I couldn't have done this and I couldn't have done this without that right triangle addition that I added, yes? But now I can use what I got to suddenly only talk. Now I'm not talking about this thing at all. I'm only talking about this weird ass little freaky scalene dude. Yes? I love you guys. What can I do here? If I gave you this, what would you do? How do you mean? If I said do this by hand, what would you do? Kick me and leave. I don't blame you, but what would you do if you actually...
What, 48 by 48?
Alright, so how do I do this?
Multiply it.
Write it twice, yes?
Yeah.
Alright, so how do I do this?
Write it twice.
Alright, do it. I'll wait. Write it twice. Foil, distribute. Don't let what's in there freak you out. We're the humans. We're in control of this shit. Yeah, the letter C kind of sucks. It looks like a parenthesis, but we'll be all right. So B cosine C times B cosine C is what? So B squared cosine squared C. And then I get minus AB cosine C minus AB cosine C. So I get minus 2 AB cosine C's. And then I get at the end, negative A times negative A is, negative A times negative A is plus A squared. And then I get the rest of the stuff. What is this? B, what's being squared?
C.
Yeah, everything. So B squared sine squared C. Now, quick little side note. I can't remember how much I emphasized this. I really hope I said, I think I did say this. Did I talk to you guys about sine squared plus cosine squared? That's okay. That's my fault. So go with me just for a second, guys. In a unit circle, this is 1, yes? This is theta. Just go with me, just watch. What is the sine of theta? Y over 1, so it's y, yes? And what's the cosine of theta? X. Is everybody with me? Come back. Stay. Thank you. From the triangle, what is x squared plus y squared? What's x squared plus y squared? From the triangle. Old Greek 2. What's old Greek 2 said? X squared plus y squared equals? 1. What was x? What was x? Cosine. So cosine squared plus sine squared is 1. Here, let's check it out. What's cosine of 30 degrees? Yes, because it's close to x. What's sine of 30 degrees? 1/2. What is the square root of 3 over 2 squared plus 1/2 squared? Don't say 1. That's what we're going to prove it's 1. What's square root of 3 squared? You can do it. What's square root of 3 times square root of 3? 3. What's 2 squared? 4. What's 1/2 squared?
1.
And what's 3/4 plus 1/4? 4/4, which is 1. All right, so we didn't prove it, but that does, well, we already proved it. There, we proved it, and here I'm just showing you, holy shit, it's true. If you do that for any angle you want to, it'll be true. So when is cosine squared theta plus sine squared theta equal to 1? Always. As long as these are the same angle, that is true. So, with that in mind, does anyone see a cosine squared and a sine squared? Are they talking about the same angle?
Yeah.
Yes, so let's get those together. They also have other shit on them, yes?
Yeah.
Poor little guys. We'll clean them off in a minute here, let's see. Okay. Do you see what I did? I just moved him over there. Because like you just told me, you saw a cosine squared, you saw a sine squared, they're both talking about the same angle. They both have a stupid b squared on them though, so how do I kind of move that out the way? What can I do right here?
5 by b squared.
No? Not really. Just factor a b squared out. Oh my god. Law cosine is a little long. What is cosine squared plus sine squared? Cosine squared c plus sine squared c is 1. So look at this. I'm going to reorder this. Isn't there an a squared here? There must be because I just underlined it. So yes. Isn't there a b squared times 1? Isn't there a b squared here? This is 1, yes? So I got a squared plus b squared minus 2ab cosine c equals c squared. So if I cover this, what is that? No, what is that? A squared plus B squared equals C squared.
Yeah.
What is that?
Pythagorean.
Yes. This, I love this. I love this. I need you guys with me. That's 1. B squared times 1 is B squared. I have A squared plus B squared minus this equals C squared. Yes? That is an adjustment if your triangle is not right. In fact, what do I get here if C is 90 degrees? What if I do have a right triangle? What is the cosine of 90 degrees? 0. So if C is 90, that just becomes the Pythagorean theorem. So this is an adjustment term if you don't have a right triangle. So what if C was 89 degrees? Well, I would just put an 89 right there, and then I could still do this. So we have taken Pythagorean theorem, which only works for right triangles, and we've extended it to work for any triangle. I just have to plug in the value of C. Let me stop. You guys with me? To me, that was so trippy when I first saw this. I still remember that day. Because there's the Pythagorean theorem. And if C is 90, it's just the Pythagorean theorem. But if C isn't 90, it's an adjustment. It's just a little adjustment for the poor little triangle. This is not really a right triangle. So let me show you this. We did this for this triangle. Couldn't I have called this B? I need you with me. Couldn't I call that B? I could have called that C. I could have called that A. Yes? I could have set it up whatever way I want to. So watch this. One formulation for the law of cosines is this. If I moved all my letters around, I could have gotten this formulation for the law of cosines. If I moved all my letters around, I could have gotten this formulation. Sorry. Okay. No, Jeff. I got overly ambitious. Do you guys see kind of like a pattern here? That angle and that side, that angle, that side, that angle, especially now when I change it to that side. And then the other, it's B squared, C squared, BC. AC, AC, AC. AB, AB. So let me give you the worksheet that you know I have. We'll do this first problem together, and then I'll have you guys work on the other ones.
What's that?
Oh, okay, guys. Alright, so let's do this first one together. This is the one from the law sign sheet, the one at the bottom. Can you guys remind me why law signs didn't work here?
We don't have one complete, like.
Yes, you can't make a complete ratio. I don't have an angle and its side. So anytime I'm given enough information, but one of the laws doesn't work, the other law will. So they're kind of nice. Together they cover every possibility. So help me out. I know angle B, that's it, yes?
Yep.
So which variation can I use? 1, 2, or 3?
3.
The third one, because that's the one that uses the angle that I know. You guys see that?
Yep.
Now, each one of these is actually the same equation, because you could just relabel this shit. But instead of relabeling this, we just pick the right one of these. So I'm going to use this one. So I got B squared equals, what's A? 8. B squared equals 8 squared. What's C? 11 squared minus 2 times 8 times 11 cosine of 16 degrees. Now listen, guys. For some reason, people do this in parts, and then they make a mistake with freaking PEMDAS. You wouldn't do this plus this minus this, then multiply. No! But just put this entire thing in your calculator. It costs enough money. Let it do all the work. So you could just throw all of this, just literally 8 squared plus 11 squared minus, I gotta make sure I'm in degrees. Yes, thank God.
15.8.
Let me catch up. I'm slow. Minus 2 times 8 times 11 times cosine of 16. I put 2 negatives. My English teachers would say, "What's wrong with you, Jeff?" Okay, enter. 15.818? Is that what b is?
Yes.
No.
Oh,
That's what b squared is. Now, real quick. Don't take the square root of this. Take the square root. Now, you ready? I think I've shown you this before. This button right here, above the negative. ANS stands for answer. So if I do square root of second negative, it'll take the square root of the last answer that showed up on the screen. That's B. It's sort of like, it's just like Pythagorean theorem. The last thing you do with Pythagorean theorem is take a square root, yes? So this is basically Pythagorean theorem, kind of beefed up a bit. Now here's the neat thing. You ready? Now that I've got B, how do I get the other angles?
angle side.
Yes, so I'm not going to use law of sines because that could screw me over. I'm just going to use law of cosines now. Don't I have all 3 sides?
Yeah.
So which angles do we not know?
A and C.
So I can pick one. I can pick either one of these because I know everything except the angle in each one of these. Do you guys see that?
Yes.
I know everything except the angle in each one of these. So let's see. Which one do you want to do? First or second? The second one? For A? Okay. So it'll be A squared. Where'd it go? There it is. A squared equals B squared. Oh, that's what we just got. 15.818. No, get out of here. A squared equals, B squared is 15.818. Plus C squared is 11 squared. Jet, the king of no room. It's amazing. Minus 2 times 11 times, there we go. Where'd it go? 15.8. No, Jeff. That's where you gotta be careful. B is 3.977. There we go. So let me make sure you guys are with me. This is A squared equals B squared plus C squared minus 2 times keep myself straight. Yeah, 2 times C squared, C times B. Yes, okay. Times cosine of A. Okay. Oh my god. So here's where people make the order operations mistake. This is 64, and then I could do in my calculator 15.818 plus 11 squared. Now the mistake people make is they'll subtract this, but that's part of this multiplication, yes?
Yeah.
Okay. So you get 136.818 minus 2 times 11 times 3.977. I subtract this and then I divide by this, yes? So I would subtract this. And then I would divide by this. So a lot of students try to shortcut this and they get to the wrong answer really quickly. this will be divided by 87.494. I get 0.8323. Good Lord. Argaba! Become a number. Okay. Now, real quick, just to show you where I am in the calculator. Yes, there it is. Now, on the paper, I kind of rounded this, but in the calculator, and I've already kind of like rounded numbers, but just not to get it any worse, I'm going to do, how do I solve this equation? How do I solve this? What do I want to get rid of? What am I trying to solve for?
A.
Good. I'm trying to solve for angle A. What do I want to get rid of? Why is A not by itself? What is with A? Where is A? It's stuck somewhere. It's inside of a cosine, yes? So do I have A by itself yet? No, I know the cosine. How do I kill cosine? Do not tell me divide. I will weep in my weeping corner. Huh? Yes. So take the inverse cosine of both sides. So look what I'm going to do in my calculator. I'm going to say inverse cosine of answer. Because that's the last thing that showed up on the screen, yes? I'm not going to use some rounded number. I get 33.668 degrees. Okay. Very exciting. Now listen, I understand when you're doing log cosines, students about right here, they kind of check out like, what? Answer? Okay. Because this is not exciting. You just got to be careful when you do this shit. Don't violate order operations or you get bad things happen. Shit. I don't know if I can get this line. There we go. Now listen, do I have everything yet? What am I missing?
C.
I'm just missing angle C, and that's easy because I know angle B. I know angle A. So I can get angle C easy. Okay. Why did we avoid law of sines once we got this side? Because now I can make a complete ratio. We avoided it because it could lead to multiple answers. The great thing about cosines, law of sines has issues because inverse sine can only give me negative 90 to 90, and we know bigger angles exist in triangles. Does anyone remember what inverse cosine gives me? The output for inverse cosine. So 0 to 180. If you're talking about degrees, you with me?
Yeah.
And what are all the angles that could exist in a triangle?
180.
From 0,
0.
because it could be point 0.00000000007 degrees. Up to 180. So inverse cosine cannot, the law cosines cannot give you multiple possibilities. The things that inverse that the law cosines works for won't ever kind of have that weird wobbliness that law of sines allows for. Partially because of the range. Inverse cosine gives me every possible angle that lives in a triangle. Okay, maybe. So here, what time is it? Okay, good. Can you guys try out number 1 down here? I love number 1. Actually, yeah, try out number 1. What's different about number 1? I didn't give you a damn angle. So, let's see what you think. You can work with other people if you want to or not. It's up to you. Let me or Christine know if you need some help. If you need a calculator, I've got some for you. start consolidating what you can, and then start solving it. Once you get those numbers consolidated.
Yeah. I mean, I was only right now.
Oh. We're gonna do it. Oh. I mean, it's just a bunch of algebra, really. It's just, and this was really worse because we had that kind of gross side link here.
I can't do it. Because half of the results.
Oh, true. Yeah. But let's see, if you picked, so you did 11 squared equals 15 squared plus 13 squared minus 2 times 15 times, is this the one you did?
Yeah.
Cosine B. Then you can put these together. You can multiply this out. Start making things become one number, yes? So this is 121. What is that? 390. That already looks a lot better. So now you isolate the term that has cosine. So you move the 394. Then you divide by the coefficient of cosine, and then you take an inverse.
Yeah, but wait.
You're trying to unbury the cosine, so then you can attack it directly with inverses. So you want to find the term with cosine in it. There it is. Get rid of the other thing. Get rid of it.
Oh, you said about
Right,
that.
subtract it.
Yes, okay.
Do that next. Yeah, and then you can double check one level, like all down to like this below. Yeah. At least it tells you you didn't find some big mistake. It doesn't tell you that you're exactly right. And to be honest, I haven't done this wrong. So I don't even know the answers like that. Oh, yeah.
So, I'm trying to plug into the calculator, but it's not, it's just doing it.
Go back.
Where?
Well, hit go to. So it's telling me, oh, just, yeah, oh, totally, no. Okay, so why do you think that's what you're supposed to put in there? Let's see. Oh, there it is, okay. If I have 7 minus 5x, is that 2x?
You divide both sides.
No.
Okay.
So I can never put this together with this because that's a coefficient on my unknown.
Put the calculator back.
So right here, this you can multiply and replace this with one number, but then you have to subtract this and then divide by this.
Oh,
Yep.
Why is it not?
Yeah, that.
Excuse me.
The biggest output for cosine is 1, so the biggest thing you can put into inverse cosine is 1. So if you ever think you're supposed to put something inside the inverse cosine bigger than 1, you've done something. No, the other way, subtract by 94. You try to get this by itself. So if you can get rid of what's with this term, then you'll be able to divide by negative. So you'll move this over. And I know your brain doesn't like it because you'll get a negative number, but who cares? As long as you do the algebra, this isn't that bad. As long as you can keep track of what's going on here. All right, let's see. I chose this to solve for angle B. So everybody should get to a point where it looks like this. The major mistake is somebody does 394 minus 390 is 4. And of course you can't do that because these are not like terms. I got 390 of these that I'm subtracting. Those aren't like terms. I can't combine those. So I pretty much almost always subtract this guy and then divide by this guy. And that will get cosine by itself. So subtract this guy. Oh, what's that? 273? I don't know. You guys might have all done different angles. Divided by negative 390. And to be honest, I'll often do this. And then I just take the inverse cosine of that. Just because I don't like to write a bunch of decimals, so I just don't. And then I can feed the calculator all of this. And you're trying to tell me what it is. What'd you get?
45.57.
Nice. 45.573. Hiya. Degrees. Did somebody else get a different angle? Did somebody else solve for a different angle? What angle did you solve for?
C. I got 122.436.
Good. Hold on to that. Did anyone solve for angle A? What'd you get?
76.879.
What's the problem? Is it? Oh, interesting. Somebody's not right. Because all of our angles have to add it to 180 still, yes? Okay, so. Right now, I know all three sides and one angle. So I'm gonna do law of cosines again to get another angle. You guys with me? Now real quick. If I always solve for the biggest mouth, I could then safely do law of sines, because I will have already found the biggest angle. Now, if what I just said doesn't make any sense, you can just do law of cosines until you get, all I need is one more angle, right? And then I'm done, basically. So, if I try to get, I'll do you later. If I try to do, it doesn't matter, Jeff. Do A, sure. 15 squared equals 11 squared plus 13 squared. Oh my God, Jeff. Okay, hold on. I got too much crap here. So I'm going to solve for A. 15 squared equals 11 squared plus 13 squared minus 2 times 11 times 13 cosine A. So I get, what is that, 225? 225 equals, let's see, now 121 would be 390. Is that right? $290. You're just off by 100, Jeff. That's all. And then this would be whatever the shit this is. 121, 132, 143, 286. No. You're on your own, Jeff. Okay. 286. Cosine A. So if you do enough of these, you'll start to realize it's almost always the same kind of like steps. Subtract 290. What is that, math boy? 65. Divide by negative 286. And then take the inverse cosine of both sides to get A. So if I take the inverse cosine of 65 over 286, I get 76.863. Now if I want to get the last angle, I would just add these two, and subtract from 180. And when I add these two, I've already got 122.436. Oh my God, I think that's right. All right, let me stop for a minute. Whatever angle you chose to solve for, did everybody kind of have similar steps to this? Yes, so when I give you three sides, it's going to be the exact same kind of steps. The big mistake is to think you can combine these, but you can't because they're not like terms. Subtract, divide, inverse cosine. Same thing happened up here. Subtract, divide, inverse cosine. And now to get the last angle, I just add these two and subtract from 180 because all the angles have to make 180 still. So let's see, Jeff. Were you right? I think so. So I get, for angle C, I get 57.564 degrees. Now real quick, who said 100, was it Dylan? I don't want to pick anybody. Did you use it, law of science?
Yeah.
Ah.
No, I use a lot of them.
You got 100 something? What did you get exactly?
122.4.
436?
Yeah.
Somehow you got, oh, did you lose that? Did you have a negative sign? That should have been. Where's that? Where's your word for the 100 and something?
Yeah, right.
These two negatives cancel. Yeah, you were in the wrong, that's why you ended up in the wrong quadrant. Yeah, okay. Because it was perfectly the supplementary angle, so. So guys, this part of me is fascinated here because all I was given was the sides and somehow we managed to get the angles. If you really think about it, that's tricky. At the same time, if I know the sides, I kind of know which mouth opens biggest, so it kind of makes sense that I should be able to kind of get what the angles are somehow. Let me ask you about this. Considering we just did this, can somebody figure out what's wrong with this? Let me give you a cleaner one to look at. Why can't we construct a triangle with these sides? Now I know this isn't to scale. Yes, do you have it?
I was just gonna say because it's a squared plus b squared can't equal c squared.
Oh, it's not a right triangle.
Oh.
I didn't say it had to be a right triangle.
Oh.
So watch this. Let's say this is 3. Just go with me. This is 2. What's the only way? All right, let's see how I can do this. Oh, maybe I draw this. If this is 3 and this is 2, if I laid these right next to each other, how long do they become?
5.
If I give them, is everybody with me? That only makes sense. 3, 2, amazing. If I give them a little bit of an angle, this has to be less than 5. So, and of course, if I lay them right next to each other like this, can I make a triangle out of that? No, I need a little bit of a curve so I can fit those two together, yes? And the minute I do this, that side's got to be less than 5. So why did this triangle work and this triangle can't? Because in order for a triangle to exist, any two sides have to add to be more than the third. What's 11 plus 13? 24. What's 13 plus 15? Bigger than that. What's 15 plus 11? Bigger than that. So that triangle exists. This triangle, what's 3 plus 2? Shit. So for a triangle to exist, if I give you all 3 sides, any two of them have to add to more than the last one. If that doesn't happen, that triangle can't exist. Because that's 5 the minute I give it a bit of a kink, so I can connect these, my fingertips,
that's gonna be less than 5. So I can't make a triangle if I need that one to be more than 5. Tripping. Okay, listen. I think we can only take so much of this. And I don't care. Let's leave early today. We're gonna leave early. So this one here, it's okay if you guys, what's happening next Tuesday, by the way? Quiz. On what? Yes, because you guys chose to not have a quiz today. So instead, it's on 3 sections on Tuesday. What's happening next Thursday? The test. I love it. Cool. Alright, that's plenty. Let's get out of here. We're done. Listen up. So next time, we'll do that number 2 problem after we take that quiz. And then we'll finish up whatever we gotta finish up. Thank you.
Today was like, what, today was like 10 point something? Or is this still 8.3?
No, this is 10-1, 10-2.
Okay.
Yeah, if I remember correctly, 10-1 is law of sines, 10-2 is law of cosines.
Mm-hmm.
I'm pretty sure that's true.